Welcome to our lesson on midsegments, and specifically midsegments on the coordinate plane. So today we're going to focus on being able to use the midsegment theorem for triangles on the coordinate plane. So the midsegment theorem says the midsegment of a triangle connects the midpoints of any two sides of a triangle. The midsegment then is parallel to the third side and half the length of the third side. So here we have this orange triangle. Our bright green segment here would be a midsegment, which would mean that this is halfway, it's a midpoint of each of these sides. It would also mean that it is parallel to this third side. So let's go do some math with this. If triangle ABC has these vertices, find the midpoint D and E. So I've already plotted the triangle onto our coordinate plane, so we need to find the midpoint. Remember that midpoint means the middle or the average. So we're going to find the middle of the x values and the y values for point D and for point E. Let's focus on point D. And I am going to do this in two different ways. For D, I'll do it algebraically. So D is involving point A and point B. So we're just focusing on that, and we do not need point C. Finding a middle or average. Average means add and divide by 2. So do that with your x values. So the x value of A is -4, and the x value of B is -2. We're going to add those and divide by 2. -4 plus -2, -6, still dividing by 2, -3. Repeat that process now using your y values. So the y value of A is -2. The y value of B is 6. So add those two and divide by 2. -2 plus 6 is 4. Still dividing by 2, 2. So this would be our point D. I'll go ahead and put that on my coordinate plane. -3, 2. D. Now I'm going to show you another way to do midpoints using the coordinate plane rather than using the algebraic method. So if I do this using the coordinate plane, I need to find how many boxes between B and C going across and down. So going across, if I count my boxes from B to C, I go 10. And going up and down, if I count those boxes, I'm going 10. So midpoint means the middle. So the middle or halfway of 10 is 5. So I'm going to count 5 boxes from either coordinate. So here's 5. And then do the same thing going up and down. Up and down I go 10 boxes, so I'm going to count 5 boxes. And where these meet will be my midpoint. So point E is at 3, 1. So that's the first part here, is we need to find those two midpoints. Once we find those, we can start looking at the slope and the length to show this. So here we want to show that the two segments are parallel. I already have D and E plotted on here. Nice clean graph for us to work from. So showing parallel means show slopes are equal. So let's look at DE. So slope is just rise over run. So if I go from D to E, I'm going to go down 1 and then over 6. Down 1 over 6. So when we translate that into slope, down means -1 over 6. And that would be the slope of DE. Now let's go show AC. We're going to do the same thing. Slope is rise over run. So from A to go to C, I go down 2 over 12. So just count the boxes. Down 2 over 12. And when we translate that into the slope value, down means negative, and then over is 12. And we want to make sure we reduce this to simplest form. So 2 goes into each of them, -1 over 6. So now we can see that we have the same slopes. Our last property of midsegments was the lengths of these segments. So DE should be half the length of AC. Remember, length means distance, which we're going to use the Pythagorean theorem for. So length of DE. To find the length of DE, draw in your right triangle. Down and across, and then count those boxes. 1 and 6. Those values that we just counted and put onto that triangle are going to make up the Pythagorean theorem A's and B's. So A squared plus B squared equals C squared. And we're going to plug in that 1 and that 6. 1 squared plus 6 squared equals DE squared. To undo my squared, we're going to square root. And that cannot be simplified, so we're done with that. Next part is finding the distance or the length of AC. So AC, the length, we're going to repeat the same process using segment AC. So I draw in my right triangle, count the boxes. Now take those values and we're going to plug them in to the Pythagorean theorem. When you get to this point, undo your squared with a square root. So AC equals the square root of 148. 148 can be reduced. It breaks down to the square root of 4 and the square root of 37. The square root of 4 is 2. Square root 37 stays the same. So the length of AC is 2 times square root of 37. We want to make sure that we verify that these are half and double. So DE is 1 square root of 37, and AC is 2 square roots of 37. So that would be doubling to go from DE to AC, or half from AC to DE. So we're all good there. Okay. So we've just gone through and done all the math to show that the midsegment theorem does work. Okay. So now, here's a problem for you to try. Okay. It's broken down into the parts. Take a moment and find the midpoint L and the midpoint K. So the midpoint L of RS I'll do this one on the graph. From R to S, I go up and over. So I'm going up 10, and I'm going over 4. So to find the midpoint, I'm going to count halfway between. So half of 10 is 5. 1, 2, 3, 4, 5. And then across is 4. Halfway of that is 2. So my midpoint, L, is right here. And that would be the coordinate -2, 5. I'll also do this algebraically. So to find K of RT, add up your X values and add up the Y values. So my X value of R is -4. The X value of T is 8. And we divide that by 2. -4 plus 8 is 4. Divided by 2 gives us 2. Then repeat for the Y values. The Y value of R is 0, and the Y value of T is also 0. Divide by 2. 0 plus 0 is 0 over 2, and 0 divided by 2 is just 0. So my point K is 2, 0. Next part of this was our slopes. So I have our midsegment on here. Go ahead and verify or show that the midsegment LK is parallel to the side ST. Alright, so the slope of K, you just count down, ups and downs, and then across, rise over run. So 1, 2, 3, 4, we go down 5 and over 4. Translating that into slope, down 5, so -5 over 4. And then repeat that for ST. So from S to T, I go down and over. So I go down 10 over 8. All I did was count those boxes. Down is negative over 8. We need to reduce this. -5 over 4. So both of my slopes are -5 over 4, which we know when we have the same slopes, we have parallel segments. And the last part of this is showing length. So go ahead and start on your length. Remember, length is distance, which is really just our Pythagorean theorem. Alright, let's find the length of LK. To find the length, you first need to draw in your right triangle and count those boxes. This is 5 and 4. Those values that you just counted become the A and B in your Pythagorean theorem. A squared plus B squared equals C squared. So one side was 5 and the other was 4. And this is for LK. 25 plus 16. $25 plus 16 is 41. So that equals LK squared. And to undo that square, we're just going to take the square root. So the length of LK is the square root of 41. We will repeat this same process for ST. Draw in my right triangle. And count the boxes. those values you just counted are my A's and B's in my Pythagorean theorem. So 8 squared plus 10 squared. And this would be ST squared. 64 plus 100 is 164. And now we undo that squared by taking the square root. So the square root of 164 equals ST, but 164 can be reduced. It is the square root of 4, the square root of 41. The square root of 4 is 2, and the square root of 41 stays as the square root of 41. So ST is 2 times square root 41, and LK is just 1 square root of 41. So yes, we can see that that is being doubled or halved depending on which way you're going. Okay. All right, so that's the end of our examples. The things that you need to make sure you remember. Midsegments connect midpoints. So finding your midpoint means you need to find the middle or the average of those values. Midsegments are also parallel to the third side, which means you're going to show that the slopes are the same. And finally, midsegments are half the length of the third side. So that's your distances. Okay? Your Pythagorean theorem you'll be using, and make sure you reduce your radicals. And that's all we're going to cover on this lesson for midsegments.